This typed video is on standard deviation, quartiles, and outliers. So standard deviation tells you how much data is spread out on average. It's like a rating that tells you an average spread or how far away each data is on average from the mean. Let's look at an example. Two classes, say like high school classes, each one of them has the same class average, 75%. But class 1 has a standard deviation of 12. Class 2 has a standard deviation of 4. So they have the same average, but the spread is very different. On average, Class 1 students are plus or minus 12% from the mean. They're more spread out compared to Class 2, who are, on average, plus or minus 4% from the mean. So more spread out. That's what standard deviation tells you. Let's look at an example from manufacturing. Suppose you're trying to make some sort of component. It doesn't matter, you don't have to be an expert in manufacturing, but you're trying to make something that's 20 millimeters big. Well, this first company or component that's making a whole bunch of these components, their standard deviation is only 1/1000th of a millimeter. There's very, very small average differences between each part. But on average, this one is 1/10th of a millimeter away. So in this case, component 1, this company's making much better components because their parts are only plus or minus 1/1000th of a millimeter. These ones are 1/10th. So you get a lot more variability with component 2's here. So standard deviation, again, telling you how spread out it is by telling you on average how much it is plus or minus from the mean, how spread out it is. Quartiles are something different. Quartiles break the data into 4 separate parts, or 4 quarters. Q1 separates the lower bottom percent, 25%. Q3 separates the top 25%, and Q2 is the median. It separates the middle. You know, I always teach it now with thinking of a block of wood. Imagine this thing here was a block of wood. Cut it down the middle. You cut this down the middle, that's Q2. You separate it in the median, and you got half the stuff below, half the stuff behind at the top. Now you cut the bottom half, the yellow here, the bottom half of wood, cut that in half, that's Q1. And now you got 25% here, 25% here. Your top half of block, which I left white, cut that in half. Oh, that's a little off there. Q3 is right about there. That's Q3. That separates the top 25%. And so you can see you make these cuts, Q2 down the middle, and then Q1 bottom half, Q3 top half, and you get 4 quarters based on these 3 boundaries. And my numbers have moved a little bit off here, so I'll put them back. We're about to do an example here, and I've got some visual here. So let's calculate the quartiles for 7, 9, 4, 3, and 10. We want to find the quartiles for these 5 numbers. First, arrange them in order. So rewrite 7, 9, 4, 3, 10 as 3, 4, 7, 9, 10. Remember to put them in order. It's crucial. Okay, well, looking at this, Q2 excuse me, is 7, the middle number. Easy, it's just the middle number, that's Q2. Half the numbers are below 7, half of them are above, and I separated that into 2 yellow blocks here. And I labeled it on this diagram, that's the 7. How do you find where Q1 is? You look in the middle of these bottom numbers. What's the middle of 3 and 4? Well, there is no middle number, so take these 2 middle ones, add them up, and divide by 2. You get 3 plus 4, which is 7, so 7 over 2. Q1, as shown on this diagram, is 3.5. And then for the middle of the top half, we take the middle of 9 and 10. There's no middle number, there's just 2 numbers, so take the middle of these middle 2 numbers, excuse me, and you get 9 plus 10 over 2, which is 19 divided by 2, aka 9.5. So 9.5 represents the middle of the top half. There it is again, just calculated. Excuse me. And there it is in the diagram. There's your middle, Q2, and there's your middle, 3.5 of the lower half, and your middle of the upper half, 9.5. There's also this thing called quintiles, which separates data into 5 parts. It's just like quartiles, but instead of 25% blocks, quintiles, you have 20% blocks. You use that a lot in financial things. Percentiles work the same way as quintiles and quartiles. Instead of breaking it into 4 sections, you break it into 100 sections, so there would be 99 boundaries. It's worth talking about outliers too. Outliers are when one or sometimes more of the data is so extremely far away from the rest of the data that you think this can't be right. It's some sort of anomaly. Something really went wrong with that particular thing. Think of like an error on a printing machine or some sort of like piece of food in the cereal that didn't come out quite right. You wouldn't count that in your data. It's something went really wrong, not just with manufacturing, but with any data where we think that data doesn't really belong. It doesn't really reflect what's coming out. It's some sort of error, and we remove the outlier from the data. You kind of have to make a decision, though, on how far away it is. In this case, you see here a long list of numbers, and most of the data we don't even know. Oh, it does say we're filling up soda cans, which are supposed to be 355 milliliters, I should say. You're trying to get 355 milliliters, and you got close on most of these. It's filling up the soda can with the right amount of liquid, except for this one, 186.7. We have to make a decision. Did something go wrong on the production line there? Was it actually representative of we're getting cans a lot that are being half filled? Or is it that something just went wrong on the run there and we reject that? It's not a good part of our average. Same thing with marks. Here's a list of marks, and you can see the student is generally getting in the 80s, sometimes 90s, sometimes high 70s, but there's this one mark, 23. It could be that's a legitimate mark, that they just didn't study, or it could be maybe something really bad happened, some sort of tragedy in the student's personal life, and does that mark really count? Again, when I and other professional teachers go to look at your marks, we try to make professional decisions. Does this reflect poor choices, or was there something else going on in your life that makes this an outlier rather than a reflection of your knowledge? Same thing for these ones. You look at these marks here. For the part B, I probably would assume 23 is an outlier unless I had more information that the person just didn't study. But for part C, you have a 34 and a 24 and a 43. These marks are up and down all over the place. I don't think any of those are outliers. So outliers, it's when it's far away and usually a lot rarer, but in the end, you're going to have to make a personal decision. Is it truly an outlier, or does it legitimately just a bad result?